In this video, I will explain why residual networks work. So say we have an input, let's say XL, and what we do is, let's say we pass it through ReLU, convolve it with the weights WA, and then pass it with another ReLU, convolve it with weights WB, and then add it to the original input XL. So this is basically the learning of a residual block, right? So here's our XL, that's our original input, and then it passes through ReLU, it convolves through WA, and the whole thing passes through ReLU again, convolves through WB, and then our original input XL gets added to give us XL plus 1, the next output to the next level. Now let's see various cases. It is possible that the output of this convolutional layers may be something meaningful, or maybe the output of these convolutional layers is something totally garbage, right? Now, if the residual block learns something reasonable, then the output that we have, XL plus 1, is something reasonable plus our previous input, XL. So if we add something reasonable to our original input, obviously what comes out is something more reasonable. That is something that actually helps us classify the input. On the other hand, if the residual block weights are closer to zero, let's say either during L2 regularization or something happens, and these learn almost nothing. That is, the output of these is there's vanishing gradient, there's some problem. So the output of the convolution, let's say, is almost zero. So this part, this block, gives us something zero. So we add something zero to the input XL, then what comes out is something very close to XL or the XL itself, right? So in this case, our output XL plus 1, the information is not lost, right? So even in this case, the residual networks, the residual network, I mean, it's still in the direction to either maintain what it already has or at least not lose what it has learned. Now, if the residual block weights are closer to 1, so say, for example, there's exploding gradient problem, and exploding gradient problem, then the output here is something reasonable, which may be close to XL itself or just multiplying by 1. So the output can be XL times 2 or added a constant. And in that case, the output is again still maintained. So what we see here is that overall, no matter whether this block, the convolutional layers in a residual block learn or not learn, residual blocks always either maintain the knowledge or improve upon the knowledge learned from previous layers. And this is the reason why residual networks work.